David Smith here with one more flipped classroom math video. 3 tips before we start. First, remember that you can slow down or speed up the playback if that helps you follow along. Second, you could turn on the captions and watch my words go by on the bottom of the screen. And lastly, you can pause the video at any time to catch up with your notes or think about the topic. In this lesson, we're going to cover how to find the equation for tangent lines and normal lines at a point on a trigonometric function that uses sine or cosine or both. So basically, if you recall from the fall, we worked on finding equations of tangents and normals to other types of functions at certain points on the curves of those functions. So this is the same exact process, only this time we're doing it with trigonometric functions. So let's take a look at our example. We're going to just do one in this video, but there's quite a bit of stuff, so that'll be a good video. So check this out. F of x is sine of 6x minus 3 cosine 2x. There's our function. Whew, pretty complicated. If you're interested, pause the video and pop that into Desmos or put it into your calculator. Just see what that looks like. Now, here's our prompt. Find the equation of the line tangent to f of x at x equals pi over 3. First thing you notice here, we're in radians. So that's nice. Radians are nice and convenient. So, step 1. As you recall, the way we find the equation of the tangent line is we take the derivative of the function, and that's going to give us the slope of the tangent line. And then we're going to have this point here that we can use with the slope and the point. That'll help us get the equation of the tangent line. So that's the broad outlines. Okay, first step, you have the tools from our last lesson taking derivatives of sine and cosine functions. So find f prime of x. Find the derivative of sine 6x minus 3 cosine 2x. Pause the video, work that through, and come right back. Let's see how you did. So I'm just applying my derivative rules for trigonometric functions for sine and cosine to each of these terms. So the derivative of sine of 6x, derivative of sine is cosine. So we put our cosine out. Remember, we're doing chain rule. So we do the derivative of the outside. So that goes to cosine. We leave the inside alone, 6x. And then we multiply that by the derivative of the inside. So the derivative of 6x is just 6. So we have cosine 6x times 6. And now we're doing our minus. That's from our formula. And now we're going to take the derivative of the outside. That's going to be, that cosine is going to go to a negative sign. So I have a negative sine 2x. And then I'm going to take a derivative of the inside. Derivative of 2x is just 2. And actually this 3, probably I should have put it over here, but it doesn't matter, we're doing multiplication. So now I have, this simplifies on down to plus, because I got 2 minuses there, so I get a plus. 2 times 3 is my 6, and here's my sine of 2x. So this is f prime of x. That's the derivative of this function. Now, if you recall, from when we found these equations of tangents and normals, the next step was to find f of pi over 3. Because this is the point that we're going to try to find the equation of the tangent line. So we do need the y value for that. We only know that we're taking it at pi over 3 for x. So next step, pause the video and do this. Find f of pi over 3 and come back. Okay, I took that a couple steps further, didn't finish it. I'm going to leave that for you to do. Check this out. So right now, first step, I'm just going to plug my pi over 3 in for x in my function. Let's get this out here. Usually we put parentheses around that. So I have 6 cosine 6x. So I have 6 cosine 6 times pi over 3. There, and then this one's going to be 6 times the sine of 2x. So 6 times the sine of 2 times pi over 3. Now, all I'm doing in this next step is simplifying my fractions inside the trig function. So I have 6 cosine 2 pi, and I have 6 sine 2 pi over 3. So to resolve this out, you're going to have to think about your unit circle and what cosine of 2 pi is and what sine of 2 pi over 3 is. And just to let you know, this could quite possibly be a non-calculator question. So you'd really have to do this. So maybe make a unit circle and figure out what the cosine of 2 pi is and what the sine of 2 pi over 3 is. So you can put those values in there and then you can finish up this calculation. Okay, let's take a quick side journey to the unit circle. I've put it up there. I've just illustrated the parts that help us with this problem. Remember, you're going to need to be familiar with all the all the parts of that. I do have several review videos or videos up there on YouTube that will walk you through the unit circle. If you need a link, just reach out to me and I'll send you a link. So we need the sine of 2 pi. This is an easy one. And we also need the cosine of 2 pi over 3. Slightly more challenging, but not by much. So let's take a look. Let's pop over to our unit circle. 2 pi. 2 pi is all the way around the unit circle. So we're back here at our starting point. Sine is the y value. So remember, the unit circle goes up to +1 and down to -1. However, when you've come all the way around, sine, the y value, is at 0. So sine of 2 pi equals 0. So that got awful simple. We did all this math, and half of our function here is giving us a result of 0, which is kind of nice. It makes it simple. Second one, we need to figure out what 3 times the cosine of 2 pi over 3 is. So we need to figure out what 2 pi over 3 is. Now back over here at the unit circle, what I remember is that as you go around the unit circle by pi over 3, which is 60 degrees, you're going to get to 3 pi over 3, which is 180. So 1 pi over 3 is 60, 2 pi over 3 is 120, which puts us over here. And then I remembered that at that point, our coordinates are -1/2, comma, √3 over 2. -1/2 because we're to the left of the y-axis, so x is negative, positive √3 over 2. We are above the x-axis, so y is positive. So we are looking for the cosine of 2 pi over 3. So that's the x value of this coordinate point. So that's -1/2. So what goes in here, what goes in this place is -1/2. We're going to multiply that by -3. So we're going to get 0 plus 1.5. So our result, we found f of pi over 3 is 1.5. So that means the point of tangency is pi over 3, comma, 1.5. This is a step that we did before when we were finding the equations of tangents and normals. We're just doing it in a new context. Okay, third step. Let's summarize what we got so far. We found the function, the derivative of the function, and the purpose of the derivative function is to give us slopes of tangent lines at points. Then we needed to get the y value of that point of tangency. So we plugged the x value into the original function, and that's the step we did on the last board. So now we need to find the slope of the tangent line at that point. So what that means is take f prime. So we put the x coordinate into the derivative function, and that will give us the slope. That's like what the derivative function does for us. It gives us the slopes of tangent lines, or the rate of change at that point. So I've copied for you from our last board. Here is the derivative function, 6 cosine 6x plus 6 sine 2x. Now what I want you to do is I want you to pause the video and do f prime of pi over 3. So go ahead and at least do your plug-in and your simplification step, and then maybe take a look at your unit circle and see how far you can take this one. Okay? So I did my plug-in step for you. I just plugged in my pi over 3 for x in my derivative function, and I went ahead and just did a plug-in step so that I could see what was going on, and then I simplified my little fractiony things inside my trig functions, sine, cosine, and sine, and I got these values. Now, pause the video, take a look at your notes, maybe from that unit circle diagram that I conveniently erased over there, but you should have it in your notes because you can use that to simplify that all the way down and get to an answer, to get to the slope of the line that's tangent to this function at x equals pi over 3. Okay, let's see how you did. So cosine of 2 pi is 1. We've come all the way around the unit circle. We're back at start, and cosine is the x value, and cosine is 1. So we have 6 times 1 there, and then sine of 2 pi over 3, that's that same point we were looking at the cosine for. So if you recall from that board, sine of 2 pi over 3 is √3 over 2. So now we have 6 times √3 over 2. So this resolves down, that becomes 6, and 6 times √3 over 2 is just 3√3. So the slope of our tangent line at where x equals pi over 3 is 6 plus 3√3. Don't worry, that's a perfectly good slope. You don't need to freak out because it's got 2 terms and a root in it. That ultimately is just one number that's a slope. All right, here we are at the final prompt for finding the equation of the tangent line. Find the equation of the tangent line. There's your prompt. Now here's the information that you need. You have the slope and you have a point. Now back all the way back in linear equations, you know that if you have a point and a slope, you can figure out the equation of the line. So I'll give you one prompt, one hint, and then I want you to go ahead and do that. So what we have is you could use this equation, y equals mx plus b. And what you're going to need to do is you're going to need to manipulate this to find your b. We don't know what the intercept is, but we know our x and y, and we know our slope right there. We can plug all that in and rearrange and solve for b. So go ahead and do just that. All right, here's what I get. I set up my equation, I did my plug-in with my y, but we know our y, that's our y value for the point we have for this line. So I did 1.5 equals m, here's my slope, m times my x value, that's from the point, plus b. This is our one variable right now. So now it's just a question of combining and figuring out. So I left my 1.5 alone, I did my distributive property here, which gives me 2 pi plus 3 root 3 pi. That's what happens when you multiply these two terms out, plus b. And so I just move these over. So my b is 1.5 minus 2 pi minus root 3 pi. Pretty cumbersome formula, especially when I translate it into the formal equation of the line. I have y equals 6 plus 3 root 3 x plus 1.5 minus 2 pi minus 3 root 3 pi. And that root is not over the pi. Now, if you had a prompt for an exact answer, you have to stop here. If you're on a paper 1, a non-calculator portion of a test, you're really not going to want to plug and chug that out. You're going to want to stop there. But I know a lot of you just want to see it in a much more easily digested form. So I went ahead and pulled out my calculator, and what I get is y equals 11.2x minus 10.2. So there's our linear equation for the tangent line at the point on our function here at pi over 3. Woohoo! Okay, last one. Let's go ahead and finish this out by finding the equation of the normal line. So prompt number 5. So to get you started, the slope of our normal line is the negative reciprocal of the slope of the tangent line. So I just flipped it. I have 1 over negative 6 plus 3 root 3. So that's our tangent line slope. It's at the point of tangency. So the point we're going to use is the same as the point we used the last time. So I want you to pause the video and do that calculation. And I'm going to give you a choice. You can pretend like you're allowed to use your calculator because a quick, easy first step is decimalize that. Otherwise, you're going to have a bunch of algebra to keep track of. Now, I'm going to go ahead and do the algebra because I think that's important for us, but I will convert it to a decimal at the end so you can see what it ends up being. Okay, let's see how you did. Let me walk you through this. Hopefully it all makes sense. So, like we said before, here's our slope of our normal line, negative reciprocal of the slope of the tangent line, and it also passes through the same point, pi over 3 and 1.5. So, plug in step. 1.5, that's our y value, equals the slope times the x value, plus b. Okay, cool. So, next step, I just simplified this. I brought my pi over on top. I multiplied the terms on the bottom by 3, and I get 18 plus 9 root 3. So it's pi over that plus b. That's what 1.5 equals. Rearranging that, I get my b equals 1.5 plus pi over 18 plus 9 root 3. So that's my b. Whew, that's kind of a mouthful there, but we can do that. So now I just plugged that all in and got this really cumbersome equation. Y equals minus x over 6 plus 3 root 3 plus 1.5 plus pi over 18 plus 3 root 3. Woohoo! Now, for you decimalers out there, I went ahead and converted it into a decimal equation, and it looks like that one. Y equals minus 0.0893x plus 1.635. Those are decimal approximations, so it's not perfect, whereas this one is actually exact. So, if you had a prompt for exact, that means don't pull out your calculator and use decimals because you're not going to get all the points for that. So there you go. Oh, hey guys, Just one more thing before I let you go. I just wanted to let you know that I'm approaching 2 milestones this week. I will be recording my 500th video for YouTube. Woo-hoo! That's quite a milestone for me. And then second, I'm going to hit 800 subscribers as well. So I just wanted to take a minute to thank all of you out there for helping me grow this channel, for watching my videos, for making comments, for liking, and for subscribing. It's been an awesome journey, and it's not over yet. Now that you've watched the video, jot down a couple notes so you can ask questions at our next class. Remember that you can also watch the video again just to deepen your understanding. Lastly, if you enjoyed the video, please click like and subscribe.